The turnout was around 50 students, I think, or 58 right now. But the number of people who have answered is about 36 people who have answered. So I don't know why the others are not answering. The reason is known to them. It's their personal reason. Anyway, so regarding the first question, I2C protocol was conceived by whom? So the answer for this is the Philips Semiconductors Limited. So Philips Semiconductors were the one who had put forward what we call this protocol called as a I2C protocol. Next, coming to the second question, the I2C protocol is a dash serial communication protocol. So it is a synchronous half duplex serial communication protocol. So many people have answered it well. So around 75% have answered it correctly. Right? Even the first question, 67%, major percentage have answered it correctly. Then coming to the third question, the I2C protocol supports serial data transfer order. So the answer is MSB bit first. Most people have answered LSB bit first, but 44% have answered least significant bit first, but the answer is most significant bit first. The serial data transfer order is most significant bit first. Even during the programming, when I was writing the program, I had discussed the programming logic for most significant bit first order, but in spite of that, you people have not been able to remember it because we spent some time trying to discuss the bit level operations of sending a bit and receiving a bit, but people have forgotten that and given majority of the answer have been given as LSB, which is not correct. Okay, so that's the third question. Coming to the fourth question, the I2C protocol supports dash bus. So it supports a two-wired bus. SCL and SDA are the names of the two wires or two lines. Okay. Next, the fifth question is ARM supports load store instructions. So in which only one unit of data, that is 32-bit data, can only be transferred in one instruction. Is it true or false? Most people have written true, which is not correct. See, the load store instructions in the ARM support 8-bit data transfers. It supports 16-bit data transfers. It supports 32-bit data transfers. Apart from that, you have load store multiple instructions which support more than 32-bit data transfers. Okay, so since it supports a variety of byte transfers, 1 byte or 2 byte or 4 byte or sometimes even more than 4 byte transfers, sets of 4 byte transfers, hence the answer is false. The answer is false, but many people have given that as true. Next, coming to the sixth question, since ARM supports two instruction sets, it features dash code density. So I discussed this that ARM architecture supports two instruction set. One is called as the ARM instruction set, which is a 32-bit instruction set, and the other one is a 16-bit instruction set, which is called as thumb instructions. And when an application is being written using ARM instructions, it tends to take more space. When the same application you try to rewrite it using thumb instructions, the number of instructions may slightly increase in terms of the number of instructions that were used with ARM, but the overall code size or the space taken in the memory will be less because though the instructions are more, the size of the instructions are less, and we call this feature as high code density. So the answer is the first one. Many people have answered it correctly. Congrats, 64%. Next, dash unit of ARM is called as fast multiplier. So what is the multiplication unit of present in the ARM architecture is, so actually speaking, the ARM7 architecture which I had shown has a MAC unit, but if you go to the earlier versions of the ARM, maybe between ARM1 till ARM6, there were versions of the ARM core which did not come with a multiplier. So there was no multiplier, and since there was no multiplier, the concept of having a multiplication instruction was also not there. So if at all multiplication had to be done in the previous ARM course between ARM1 to ARM6 somewhere, they had to go for repeated addition kind of method, or some kind of repeated type of repeated addition kind of algorithms are there for that purpose. So they had to use that kind of method for going for multiplication. But thankfully, the developers of the ARM had incorporated a multiplication unit into the ARM7 onwards, and that was later be called as a fast multiplier, and that is referred to as the MAC, multiplier and accumulator unit. Okay, so multiplier and accumulator unit. The ALU does not do the multiplication over here, as we had seen in the data flow model. ALU does not perform multiplication here. The multiplication is done by the multiplier and accumulate unit, that is called as abbreviated as MAC unit. So the answer for the question is MAC unit, but 42% majority if you have written barrel shifter. Barrel shifter is doing a shift operation. You can also take the shift operation as a primitive operation which performs multiplication by 2, like that, 2 power, but that's called as a primitive multiplier. Okay, it's called as a primitive multiplier. So with the barrel shifter, multiplication by 2 power n can be done, or division by 2 power n can be done, but barrel shifter is not called in ARM architecture as a fast multiplier. The fast multiplier is called as a MAC unit. So the answer to the 7th question is MAC unit. Next, coming to the 8th question, the ARM7 is having 7 modes of operations. Okay, sorry, it's having modes of operations, and which are divided into mainly 2 categories. One is called as the privileged mode, and the other one is called as the non-privileged mode. Under the privileged mode, we have about 6 modes, and under the non-privileged mode, we have about 1 mode. Hence, the answer to this question is 2 modes, and there are actually 7 modes. Mainly 2 modes, which are divided into 7 types of modes. Okay. Next, we have the 9th one. The default mode of the ARM core upon reset is the supervisor mode. So among the 7 modes, supervisor mode is the default mode of operation, which is also called as the mode in which the operating system kernel may execute, if at all an operating system is being designed for the ARM architecture. The last bit is, if you remember, when we looked at the CPSR register, the previous class or classes, we had seen that the most the bits of the CPSR register, which is bit number 0 to bit number 7, this is called as the control bits or control field. So in this bit number 0 to bit number 7, bit number 0 to bit number 4, that is 5 bits, are used for the ARMS mode selection. And among this ARMS mode selection, the following are the numbers. I'm just giving you that. So 0x 1 0, next you have 0x 1 1, then you have 0x 1 2, then you have 0x 1 3, then you have 0x 1 7, then you have 0x 1 b, and then you have 0x 1 f. So as you see, guys, these are the different values. Now, if you take the binary value of them, what will be the binary value in terms of 8 bits if you take, or 5 bits if you take? 0 0 0 0, and then this is 1. Next you have next one is 1 0 0 0 1. Next you have 1 0 0 1 0. Next you have 1 0 0 1 1. Next you have 1 0 1 1 1. Next you have 1 1 0 1 8 plus 4 12 13. V is 11. 8 plus 1 1. Okay. Next you have 1, 1, 1, 1, 1. So if you observe the binary value over here, the most significant bit, that is bit 5, always remains fixed. Hence, the answer to that question, one bit status among 5 bits used for the ARM mode selection always remains same. The answer is true. So 78% have answered that. Congrats for that. Okay, guys. Is it okay, guys, regarding this? Any questions you would like to ask? I hope the questions were informative and revision oriented. Yes, people, am I audible? Okay, so were the questions helpful and revision oriented? Seventh question. Answer for the seventh question. What is the seventh question? It's called as a MAC unit. Multiply and accumulate unit is also referred to as by another name called as the fast multiplier. That's the answer to the question. Barrel shifter is not a multiplier. It can be doing the operation of multiplication with 2 power n, but it cannot do all multiplications. Division it can do, which is divided by 2 power n, but not all divisions. So it cannot be called as a fast multiplier. Incrementer is not a multiplier. Register file, which consists of 16 registers, is not a multiplier. Hence, the answer is MAC, multiply and accumulate unit. 10th question answer, again I have already just showed to you that if you take the binary settings of all the modes of operations, the most significant bit for all the binary settings of the modes of operations is constant as 1. Hence, the answer is true for that. 1 bit status among 5 bit status used for ARM7's mode selection in CPSR register, CPSR, remains always same. The answer is true. Okay. Okay, so stopping this one now. I'm launching the next what we call set of questions. So try to answer them. You have about 10 minutes starting from now. Okay, people. So these questions were on TCP/IP revision. First question, many people have answered well. Around 58% have answered it correctly. Remaining have answered it wrongly. Okay, so it's class A because the first byte is within the range of 0 to 127. Next, coming down to the second question, the loopback address is an address used to send a packet from a dash to a dash on the network. So the answer to this question is from a host to itself. Loopback packet is used mainly to send a packet from a host to itself to test what we call the TCP/IP protocol suite, whether it's working properly or not. At the same time, also for testing the client server application on the same computer, we can use what we call the loopback address. So most people have answered wrongly. 42% have answered wrongly. That is router, all other host. So the answer is the last one, host and itself. Next, third question. 1 second, please. Third question says, what is the destination? What destination address can be used to send a packet from a host with an IP address to all hosts on the same network? That means a host with an IP address 188.1.1.1 wants to communicate a broadcast packet to all hosts within the same broadcast network. So for that, you have to use what we call the limited broadcast address. The limited broadcast address is 255.255.255.255. But most people have answered as a direct broadcast address, which is 188.1.25.25, which is the wrong answer. So when a host has to broadcast to all hosts on the same network, it has to use limited broadcast address, which is a class E address, not a direct broadcast address. So the answer for the third question is the third option, but not the fourth option. Most people have answered the fourth option. Next, a bridge can access to the dash address of a station on the same network. A bridge can access the link address. A small, I think, correction, grammar correction or sentence correction in the question is a bridge can access the dash. So the two should not be there. A bridge can access the dash address of a station on the same network. So the answer to that question is the link address or the physical address or the MAC address or the hardware address of the station on the same network. That is the property of a bridge. Next, coming down to fifth question, IPv6 has a dash bit address. So 55% have answered correctly. Many others have answered wrongly. So the answer is 128 bits. Next, sixth question, checksum in the IP packet does not cover the header and the data. Checksum in the IP packet only covers the header. Checksum in the UDP packet covers the header as well as the data, but checksum in the IP packet covers only just the header. So this is a theoretical information. Checksum in the IP packet covers only header, whereas checksum in the UDP packet covers both data and header. Which of the following is not an IPC event? Which of the following is not an IPC event? Many people have answered it wrongly. 34% have answered it wrongly. So socket is an IPC event. Shared memory is an IPC event. IPC stands for what? Inter-process communication. So shared memory, socket, message queues, all these are used for sharing information between process and another process, like that. Whether the two processes are residing on the same system, you use the local IPCs such as message queue, shared memory, even socket can be used to a certain extent. But if you are having two processes on remote systems and you want to share information, then you use the socket, of course. Semaphore is not a IPC mechanism, but more it is called as a synchronization mechanism. So the answer is semaphore is not an IPC event. Then coming to the eighth question, socket is using dash. So socket refers to combination of a port number as well as an IP address is called as socket. But since the IP address is not mentioned over here and memory address is given something, so the answer for this question is only port number as of now. If it had been mentioned port number, IP address, both A and B, then the answer should be both A and B. But since the options have not been given like that, so for the option port number only is the answer as of now. Most people have given all of the above, which is not correct. Next, coming to the ninth question. Out of these, what is the major difference between sock_stream and sock_dggram? One is used for TCP and the other one is used for UDP. So that is, what is it? Both are same is not correct. One is fixed length. To that extent, yes, one is not fixed length here. SOC stream supports byte stream communication with no message boundaries. SOC dggram is also not of fixed length. So one is sequenced, the other is non-sequenced, also is not correct. So one is used for TCP and the other one is used for, wait, 1 second. Just hold on, please. One is used for TCP, other is for UDP, that is correct. One is sequenced and the other is non-sequenced. The third option here, sorry, the fourth option here also has something to be considered, because in TCP sockets we have sequence numbers and acknowledgement numbers. In UDP sockets we do not have sequence numbers and acknowledgement numbers. Hence, I think for this question, the two answers will be there. One answer is used for TCP and the other answer for UDP. One answer is one is used for TCP, the other for UDP. And the fourth answer, one is sequenced and the other is non-sequenced. One is sequenced and the other is non-sequenced. This is also a possible answer for the question 9. So we can say that the question 9 is having these two answers. First one and last one. Coming to the 10th question, what kind of data byte ordering is followed in sockets? The answer is big endian. Socket communication has been standardized to use what we call big endian communication. So multi-byte data such as IP address, okay, multi-byte data such as IP address or port number, in port numbers or IP address information will be passed out on the network in the big Indian order, but not little Indian order. Most people have written little Indian order, which is not correct, and depends on hardware also is not correct. So the concrete answer for this is big Indian is standardized. If your computer is little Indian, data has to be transmitted on the network by converting it to big Indian. If your computer is big Indian, no need of conversion. Data can be transferred as it is onto the network. Okay, people, did you get this? Hello, people. I hope these questions were helpful and revision oriented. Do you think you are benefiting from these questions, or do you think we are wasting time in questions and answering? Do you think you're wasting time with the questions and answers, or do you think you're benefiting from the questions?
Benefit, sir.
Okay, then. Somebody V1986N11 is asking the question. First question, please. First question answer, please. First question is a simple one. See, IP address has been given as 4.5.6.7. So you have to look at the first byte. If the first byte is within the range of 0 to 127, it is called as class A. If it is 128 to 191, it is called as class B. If it is 192 to 223, it is called as class C. If it is 224 to 239, it is called as class D. If it is 240 to 255, it is called as class E. So since the first byte of the IP address has been given as 4, it obviously lies within the range of 0 to 127, and hence the answer is class A. Okay? So that concludes this. So again, tomorrow we'll be having 20 questions. Tomorrow we'll be having 20 questions. This time 5 questions on TCP/IP, 5 questions on I2C, 5 questions on ARM, 5 questions on 8051. Oh my God. Do we have a deal or not? Do we have a deal with this?
Yes, sir.
Is it okay if I'm going to conduct questions on multiple subjects? Anybody with disagreement over here? Anybody wants to disagree that I should not conduct polling for 8051? Or is it okay to have 8051 ARM, TCP/IP, and I2C? Okay, nobody seems to be giving any restrictions. So I'm taking it as a okay. So prepare well tomorrow for 20 questions, 5 questions each from the subjects mentioned. Let's continue with today's discussion.